Hello, welcome to the Supermassive podcast from the Royal Astronomical Society with me, science journalist Izzie Clarke, and astrophysicist Dr. Becky Smethurst.
Yeah, it's Q&A time today on the podcast. We've received a lot of brilliant questions from all of you listening, so we thought let's get through a few more of them because the Supermassive Mailbox is ever accreting. And by the way, for those of you who don't know, we're now on YouTube if you would like to watch this episode, not just hear our voices, but see our faces too.
Yes, and just as a quick update on video, we are trying to do a little bit more video content on the show. So we're bringing you our bonus episodes as videos and any Q&A episodes like this. We're kind of navigating how we'll do the main ones with the interviews, but we'll have some sort of video elements on there for you as well. So just thank you to everyone who has watched, subscribed, supported the show in whatever way that you can, because we always appreciate it.
For an extra incentive of watching the video, look who else has joined us today down here. She's going to hate me for this.
Oh my gosh. Is it who I think it is?
This is the Pip content you're all here
for. That's really what we're here for, Becky. For our audio listeners, Becky is holding up her cat to the screen and Pip does not want to be on show. She's far too private for that.
She's like, I was asleep, curled up on the floor. Why did you disturb me? I now have cat hair stuck all over me.
But well, this is glamorous, isn't it?
Space cat's here, don't worry.
So we've got loads of questions to get through, but I thought we would start with like an easy opener from listener Matt P, who says, for each of you, what is your most memorable or formative space-related movie or TV show and why? So who wants to go first? Becky?
Yeah, sure, I'll go first. If you can hear a weird noise in the background, it's now Pip licking the human off herself after I touched her. For me, I think I'm going to go for most formative, Matt, in how you asked, because I watched Armageddon and Deep Impact as a kid when I was like 8 years old. They both came out in like the same year. I think it was like 1998. And they really stuck with me at the time. Like, especially I remember in Deep Impact, like if you remember when like the smaller chunk of asteroid hits, spoilers, but you get that like huge tidal wave and like all of the characters trying to like avoid the repercussions. Like you've got Elijah Wood on a motorbike trying to like escape a tidal wave, like getting to high ground and all of this kind of stuff. And I remember thinking it just made the concept of space feel a little bit like closer to home, like it actually could impact us here on Earth. And so it's just really stuck with me for a really long time. Armageddon as well, just because it's Bruce Willis and it's Ben Affleck and it's Liv Tyler, like Steve Buscemi, like what's not to love? It's completely unscientific, but fine. Like, it's just wonderful and joyful.
I have to agree. Deep Impact for me was one of those films that it terrified me, to be really honest. And I was like, but it was that thing of, oh, okay, there's actually more going on around us than I've sort of ever thought about. And as you say, it just makes that aspect of you to look a little bit beyond Earth. It stayed with me, but maybe for the wrong reasons.
Yeah. I love how you said you were terrified as well. I remember that the film that I was terrified of as a child was E.T., which I don't think was the intent for E.T. But my dad tells this story.
I don't trust him, no.
Yeah, my dad tells this story that like I wouldn't go to bed afterwards. He was like, what's wrong? And I was like, E.T.'s going to come get me. And it's like, E.T.'s friendly. He had to like put like Pluto, the guard dog, like a little stuffed toy I had of Pluto, like next to my bed. Yeah. Like, Pluto will guard you.
He's not in your wardrobe. Don't worry. Yeah. How about you, Robert?
Yeah, I'm definitely a child of the 70s and 80s. So and I certainly saw E.T. as well. Didn't frighten me, I have to say. Bit older, probably. Big-headed alien wasn't quite so scary. But no, it was all like the 70s stuff. It's all like Doctor Who, Star Trek, and Star Wars. Really, it was kind of a. I don't think there was as much variety in the stuff you saw then in that particular decade. But even if supposedly Star Trek and Star Wars are incompatible, so they're not really. These are not big science things, right? They're just kind of expansive space opera stuff with big characters and the idea we're part of a much bigger universe. So maybe that last point is what the inspirational bit is. It's the writing's not always the best, let's face it, but the playing around with futures, especially in something like Star Trek, is quite fun. Just the idea of this totally different future, however inconceivable it actually is. it's optimistic and expansionary, and all of that stuff is fun. And did you know it's 60 years since the first episode of Star Trek? It's
No way.
1966.
way.
Isn't that quite scary?
That's
Yeah.
amazing.
And the original series is still
Wow.
pretty good, even though, obviously the values in it are somewhat different to those we have today, perhaps in some ways, but some good pioneering stuff in there too. So
I love it, like Star Wars. I've always been a Star Wars person over Star Trek, but I
Yeah.
particularly love, because I like fantasy more than sci-fi, and everyone's really surprised when I say that, but it's because I don't have to like turn off my astrophysics brain when I
Yeah.
watch a lot of fantasy. But when you get like the intersection between them is when I'm like, yes, 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 yes. So we cannot talk about sci-fi that we absolutely love and not mention Firefly, because Firefly, just space pirates, like it just is the most wonderful show. And I discovered it so late. I think the first time I watched it, I was about like 26, 27 or something. And I was just like, how is there not more of this? Like, I didn't have the heartbreak when it was originally cancelled, but I had the heartbreak later down the line that there wasn't more than a few series and a film.
Yeah. I mean, I kind of agree with you on that one. I would say I'm quite late to science fiction as a genre. Like, I didn't watch it growing up, and I sort of got into it like in my teenage years more so, I'd say. But I've always loved cartoons, so I'm not going to say that this is like deeply formative, but I really enjoy shows like, when I was younger, Futurama, as I've got older,
Nice.
Rick and Morty.
Oh, I love Rick and Morty.
And just like how they play with maths and space science. And it's like that really fun, bonkers creativity kind of partnered with real maths to an extent that then gets a bit creative. And I think that is the thing that stays with me. It's just like how much fun they have with it. And using loosely science and maths and space to then go into the ridiculous, and it's just like entertaining, and you watch it unravel in all of the most bonkers ways possible.
You have to suspend belief, don't you? It's
Yeah.
like you can't sit there and critically analyze the science in a film, otherwise, it's a work of fiction, right? We've got to suspend belief.
Hey,
in these
I've made a
things.
career
We just
doing
enjoy
that,
it.
Robert. Like,
True. Yeah, true, but hopefully not. Well,
no, but
actually,
it's
no,
a
you probably do during the film.
tool. It's a useful tool to like, almost like Trojan horse,
Yes.
like science
Yeah, that's true.
learning into the sci-fi, right? And people watch this stuff and then do get curious about what stuff is the science and what stuff is the fiction, and it's fun to sort of explain to people where that boundary is. And there's a lot of
Exactly.
people that do that.
I think warp drives is definitely a boundary, isn't it? Really, it's just.
But like when you were talking about like Rick and Morty, Izzie, we did the multiverse episode, which was
Yeah.
sort of around Rick and Morty. But then also like, I don't know if you've ever seen some of like Simon Singh's stuff with like The
Yes.
Simpsons and Futurama and stuff, where he talks about the maths of The Simpsons. That is one of my favorite books. And like,
Yeah. And I remember when I was 16, I went to a lecture at the Institute of Physics in London, where I think it was done by Matt Parker from The Spoken Nerd,
Yeah, Matt's
who
great.
did the maths and science of Futurama and The Simpsons. And for me, that was like in that peak of doing GCSEs into A-levels. I was like, okay, no, this is absolutely my bag. Like, let's go.
Can I make a career out of this?
Yes, yeah, exactly. Okay, well, that was a great question. Thank you so
nice
much,
way to
Matt.
warm us up, Matt. Thank you. Maybe it was Matt Parker that sent
Maybe
it
it
in.
was.
It says Matt P. So
Hello, Matt. Is that you?
if you're listening, Matt.
What a full circle moment. Okay, Becky. So listener Joe has emailed with what is arguably one of my favorite questions that the show has ever received.
Okay.
He says, hello, I have a stupid question about a joke I read recently. The joke is that space could be full of vampires, but we can't see them because telescopes use mirrors and vampires don't have a reflection. So, do all the big telescopes used by astronomers / astrophysicists use mirrors? If yes, could space vampires be dark matter? And how many space vampires would there be? I know dark matter makes up about 27% of the universe, but I can't find anything on the amount of mass that would be. If a space vampire has the same mass as an average person, how many space vampires would you need to make up 27% of the universe? Love your podcast and thank you in advance if you choose to answer these questions that have been haunting me all weekend.
But haunting. Love it. That is absolutely brilliant, Joe. Like, don't know where that I love your brain, let's put it that way. And the funny thing is, I was literally talking to someone the other day about I have this bugbear with like the folklore around vampires and werewolves, because it's the whole like they can't go out at night, vampires, but the moon is just reflecting sunlight, so it's more sunlight. So really they have a threshold of how much sunlight they can go out in, and the full moon's usually like 10% of the brightness of the sun. So there's a threschhold for vampires,
I feel
Maybe
like
they
another
could go out
YouTube
on
video
really
is coming.
cloudy
Here we go.
days. Yeah. And werewolves as well. Like, what's so special about a full moon? The entire moon is still there. Then again, they have a threshold that works in the opposite way, right?
Yeah.
Yeah. Presumably, if a werewolf is out, a vampire is not. So anyway.
They can't. It's like the sharks and the jets.
Yeah.
They can't mix.
Anyway, that was a musicals reference for anybody.
Gosh,
who
we're
didn't get
getting
that.
really off course.
Anyway,
Back to
should we get back to the
vampires.
serious science of working out whether space vampires could be dark matter? So to answer your first question, Joe, yes, all pro telescopes these days use mirrors. I know amateur astronomers particularly love refractors because lenses, their purity, everything like that. But it's very, very difficult to make a big lens. Some of the pro telescopes that we're trying to build now are 40 meters across, but even so, like starting to get like a 10-meter, lens is ridiculous, right? Heavy glass lenses, they start to warp under their own weight. They're not going to bend the light the way you want them to focus them. So you just don't want to do it. So we stick to mirrors, basically. And then getting to your other question about whether space vampires could be dark matter. I mean, if we're speaking about technicalities, we technically have no evidence against the idea that dark matter could be space vampires. So I love that Joe sent this question because it lets me do one of my ridiculous back of the envelope calculations that I love so much.
The giant envelope returns. Yep, here we go.
Yeah. So the 27% number that Joe quoted for the fraction of mass in the universe of dark matter, it comes from its contribution to what we call the critical density of the universe, which we can work out at 0.85 times 10 to the minus 26 kilograms per meters cubed, or it's about 5 hydrogen atoms worth of mass per cubic meter, basically, of space. We know that critical density thanks to the equations describing like an expanding universe. They're all rooted in like Einstein's theory of general relativity. It depends on expansion rate mostly. And so we measure that with, our supernova data or the cosmic microwave background, and out pops this critical density, which basically means if dark energy didn't exist in the universe, it would be the density that would decide whether the universe would collapse back in on itself or expand forever. But we do have dark energy, so it's probably going to expand forever. So yeah. Anyway, the fraction of normal matter to dark energy then comes from like fitting a model of the universe to the observations we've got and then seeing which fraction best fits the observations best. So 27% is what we get for the best fit for dark matter. So to work out the total mass of dark matter, we times 27% of the critical density by the volume of the entire observable universe.
Okay.
Which gives 8 times 10 to the 53 kilograms. So that's an 8 with 53 zeros after it, kilograms. So it's a big number.
I was going to make a terrible joke, like, yeah, what I lift at the gym, and you're like, no.
Love it. Gotta get that protein, gotta get those muscles.
Yeah. Here we go.
Yeah. Funnily, the hardest thing to pin down for this question was the average mass of a human.
I've been thinking about this, knowing that this question was coming. I was like, how is Becky going to take this? So
yeah,
please
it
tell me.
varies wildly by
Okay.
country because of diets. It varies wildly by gender because of builds. It varies widely by age as well. So I decided there was no average number that we could assume. So I was just going to round it up to a nice round even number of 100 kilograms.
Fine by me. Let's
and make
go.
no comment on whether that's a
Order of
heavy or
magnitude
light or-
estimate. That's totally
Yeah.
fair, right?
order of
Fine.
magnitude, exactly.
Yeah.
So that means if you've got 8 times 10 to the 53 kilograms of dark matter, you'd need 8 times 10 to the 51 humans, or 8,000 trillion humans.
Okay.
Or trillion space vampires, should I say, rather than humans. So it's not really a number you can comprehend. The population of Earth is around 8 billion, and that seems like a massive number, but you'd still need 1 million trillion Earth populations of space vampires to make up that number. So it's a lot of space vampires. And if this hypothesis is proven, I think we're all in grave danger from the multitude of space vampires.
Oh my goodness. Becky, thank you so much.
And I hope you're proud of me that I refrained from making a Twilight reference in there as well.
I mean, I really think you should.
Well, you know, if we do have mirrors rather than telescopes, really, they're just all glittery up there. Maybe all stars are just Edward going, this is the skin of a killer Bella.
I can't wait for the new Nobel Prize of this to be like, oh yeah, we've done it actually. No questions, thank you.
Space vampires.
Amazing. Thank you, Becky. And also thank you to listener Joe. Wonderful question. Okay, on to slightly more, well, less fantastical questions, let's say. Robert, John Z on Instagram asks, do meteors hit the moon during showers? And could we see it happen from the ground?
Yeah, I mean, John said, how can I top space vampires?
Give it a go.
Though technically we don't know for sure that no vampires haven't crashed into the moon.
Very
hard to prove that hasn't happened.
Oh god, this is just going to be one of those things that just comes back throughout the show.
It's going to go. It is.
You know, like hexagons are the bestigons, and if people don't know what you're talking about, people are like, "What?" We're going to be like, "Space vampires."
Space vampires. When we don't know an answer, we'll be like, "Space vampires."
Yeah, it's pretty good. It's a good out clause. So anyway, the answer is that we definitely see meteorites hitting the moon, and cameras have picked up hundreds over the last couple of decades. They tend to be a bit faint, and there was one in 2014 that was about half the mass of a car, 400 kilograms, and that generated quite a bright flash, and it was seen by a guy called Jose Medido. He's got a team of people in Spain that monitor these things. That would definitely be visible in a small telescope, and you probably would have seen it with your eye as well. But, I think you have to be very, very lucky. And meteor showers tend to have smaller particles, right? So they tend to be things from sand size, pebble size, if you're really lucky, and then maybe a few kilograms at the high end. But whether it was by coincidence or just a very large Perseid chunk, the Perseid is the shower we get in August that we'll mention later on, something with about 80 kilograms of mass hit the moon in 2008 as an example. So, quite big, enough to get to a 7th magnitude flash. So the reason that happens as well is that the moon doesn't have an atmosphere, that they slam into the surface of the moon and then they're going to be destroyed. The meteorite will vaporize, it will excavate a small crater as well. But that wouldn't have been visible with the naked eye either. So it's probably something you're mostly going to see with a small telescope. But the best time to see them is during the total phase of a lunar eclipse, actually, which, as it happens, we've got quite a good total lunar or near total lunar eclipse at the end of August, because the moon's surface is then dark. So if you think about trying to see this flash against the bright lunar surface, the sunlit bit, it's going to be really difficult. So otherwise you'd probably be looking, say, when the moon was a fat crescent. So reasonably high in the sky, but you've still got quite a lot of the dark bit of it visible too. I'll just finish by saying, if anybody's got photos or video of meteorites hitting the moon, then get in touch, because I think quite a few amateur astronomers have seen these things. So the answer to the question anyway is yes, it can be done. It's a bit hard, but even amateur astronomers are getting video and photos of them.
Oh
it's
my
just
God,
being in the right place at the right time, right? You just never know what's going to happen.
Exactly. I mean, to see it with your eye, I think you'd have to be really so patiently watching for an enormous amount of time. Whereas all these smart telescopes, all the cameras that just can watch it for hours and hours, they're going to have a much better chance.
Well, that's what I was going to say. You just train it and just be like, oh, I've caught it on camera and got on with my evening. And
then we can debate whether is 80 kilograms a space vampire mass? Sorry, I'll stop.
I did think that when you said 400 kilogram, like asteroid.
4 space vampires.
But we are going to get a mission next year as well. It launches in 2027, I think is the plan, called LUMIO from ESA, the Lunar Meteoroid Impact Observer. So that's going to continuously observe the far side of the moon to catalogue like all the impacts from tiny meteorites that we know hit the Earth but burn up in the atmosphere, and we don't have a clear record of them. So Lumio is going to record like the flashes that come from those, so that we can get a better idea of, what kind of rate we're being hit by smaller things as well as the bigger things that people might catch in telescopes if they're lucky.
Oh, that's very cool. Okay. And Becky Molly Moo asks, if black holes dilate time, are there tiny pockets of the universe in different eras? Cue Taylor Swift joke.
Yeah. Oh, you're really being indulgent me today that you give me
I
Twilight
know. I was like, oh, here we go.
Swift reference. Like, it's still in a folklore era. I mean, I guess you could think of it like that. So for those that aren't familiar, Einstein's theory of general relativity says that massive objects curve space or space time, and therefore when the space is curved you can start to experience time differently as well, and so time slows down closer you get to a black hole. what you've got to remember though is that like the stuff there is actually experiencing time pass normally to them. So like if you were a person on a spacecraft, you know, going past a black hole, time would feel like it was passing normally. It's just to someone like observing you doing that, like more time would have passed. And if they
Yeah.
could see your clock from their perspective, they'd be like, oh, that clock's ticking much slower than it should be.
Yeah.
But time is like still marching on in the rest of the universe. So I guess the thought experiment I did was to say, okay, say we had the tech to do this back in the 90s and we sent like the Spice Girls on on like a spacecraft.
This is
in the
quickly
90s.
becoming my favorite episode. Yes, let's go.
Let's say like, you know, let's say we you know, we put them on the spacecraft before Jerry left, right? And see if she was still there at the back. Anyway, no, you know, maybe it would feel like if they, you know, looped around a black hole, it maybe would have felt like a year passed for them and it was still sort of like 99 to them by the time they got back to us. But it's now 2026 by the time it got back to us, because more time has passed for us. But time is passing faster because it's in lesser gravity. Like, could you say that, you know, the Spice Girls were still in the 1990s era when they're on the spacecraft, like going around the black hole? Even when they get to us, they're still in the same 1990s era. But really, it you know, the universe is still the same. It's just a human construct that like we've put on it, right, to say it's like an era. So like the timeline of the universe doesn't change. They're not in separate eras necessarily. It's just that time passes slower there, and when you pop back out again, time passes fast again, and the same, you know, a set amount of time has still passed for the universe.
Yeah. Okay. Thank you, Becky. And Robert, Mark Bookbinder, who is a big fan of the show and of Saturn, has a question about light pollution. They say, hello, I live in Connecticut and the light pollution is not as bad as New York City, but it's enough. I'm planning a trip to Montana this summer just to see the night sky. My question is, if I were standing in my yard and there was a sudden electromagnetic pulse, and all of the electric lights went out, how long would it take for me to be able to see the night sky in Connecticut as clear and as beautiful as Point Nemo? I understand light speed is fast, but how fast would it be to clear the view?
Yeah, it's a good question, right? So, Mark, we should start by saying we don't want an EMP, an electromagnetic pulse, anytime soon if we can help it, because you might get something associated with a massive space weather event, or maybe a rather depressingly high altitude nuclear explosion. We know that those generate those because the Americans and the Soviets both tried them in the early 60s and did things like switched off all the lights in Hawaii and so on, and they're actually banned under the Outer Space Treaty. However, if it did happen, then the key thing is not so much how long it takes for the light to change, because that's infinitesimally small. It's really, really fast because the speed of light is so high, but how long for it takes your eyes to dark adapt. So after the power cuts out, there won't be any additional starlight. It'll just be that it won't be competing with streetlights. So your eyes will start to change really quickly in response to that darker environment, assuming there's no moon in the sky. But the quickly is a bit relative. It takes about 10 minutes for your color sensitive cone cells in your eye to adapt, and then you'll start to see many more stars, and you'll already have a much better view than you would in say central London or central New York or any major city. But full adaptation takes about 30 minutes, about half an hour, and then you have these rod cells that only see the world in black and white. They're basically there about detecting light, and they have this chemical called rhodopsin comes in, known as the visual purple, and that's when you get maximum sensitivity. So if you go to a very dark place, then it takes about 30 minutes stepping outside, save your accommodation, to really appreciate it. And so at that point, people with the best eyes, who tend to be younger, they have eyes about 100,000 times as sensitive as they are to light as they are in daylight. So a really enormous difference. And that's when you see those, the Milky Way in all its glory, or you get those kind of scenes that inspire artists and poets, or you imagine going to some incredibly dark place, those sort of views that you see in the best photos. It's when you get closest to that, when your eyes are really genuinely fully dark adapted.
I always think if you're going to do this, do it after you go to bed at night. Like, you turn the light out and you could almost test your own eyes to see how long it takes you to dark adjust, right? Like, if you really want to test it, like leave something, like print something out in like really big lettering and leave it on the other side of the room, and then turn your light out and see how long it takes your eyes to be able to read it. Of course, if you know what it says, that doesn't help, does it? Ooh, we're really like designing this experiment now, aren't we? Right, get somebody you know,
Somebody else to write this.
to write down a word that you don't know what
Print
it is
stick
in
it on
giant
the wall.
lettering.
But only reveal it once you've gone to bed.
Yeah, exactly. Like you can't see it. So keep your eyes closed until the light goes up, and then try and read it from across the room. See how long it takes. There you go. Do your own experiment.
If someone tries this, please let us know. I mean,
Yeah, Mark.
yeah.
I mean,
Put it
Mark,
to
he
the
might be one of
test.
those people whose last name reflects their profession. So if you are a bookbinder, you even have these tools to do this, Mark. This is the Supermassive podcast from the Royal Astronomical Society with me, astrophysicist Dr. Becky Smethurst, and science journalist Izzie Clarke.
That's me. So we've got more questions coming your way. So
and Pip, we can't forget Pip. She's
and
still
Pip,
here.
she's lying on the
She's
floor.
down
Don't
there.
touch her. She doesn't want your affection. She doesn't want your
my
affection.
attention. No.
Okay, Becky, we have another black hole question from
Mhm.
Natasha Evans, who wants to know, if we could watch a star collapse into a black hole, what would it look like over time?
Yeah, actually, we think we've seen this happen. So we think it was a direct collapse of a star down into a black hole. Something that used to be like a massive red giant star right on the edge of sort of the borders of the Cygnus constellation, that in 2009, like flared up in brightness first to 1,000,000 times brighter than the sun before it dropped in brightness massively. And then by 2015, it just completely disappeared from view in visible light.
Wow.
And so the idea that was raised to explain this was that it was a failed supernova, essentially. So, in a supernova, what happens is you throw off the outer layers, right? So everything sort of collapses inwards and then rebounds. And you throw off those outer layers, and then whatever's left in the core is what collapses down to form the black hole. What people think has happened here is that while the star was still sort of in its giant phase and going through fusion of sort of like, the heavier elements trying to delay the inevitable, the core of the star was actually so heavy that it collapsed to form a black hole. And the collapsing matter formed this like burst of neutrinos outwards that just lowered the total mass of the star just a fraction of a percent. And that then caused a shockwave that blasted out the star's outer layers, brightening them, but nowhere near as much as a supernova, before then that all dimmed and then left behind nothing that we could see, presumably a black hole. And what's really interesting about this idea is that for a long time, we've known that like the rate of like large star formation, like the most massive stars, that those are the ones that become black holes, right, at the end of their lives. The sun, for example, becomes a white dwarf. It's not heavy enough to become a black hole. It just leaves behind like an inert helium core, essentially. We've known that the rate of the amount of large stars that form is actually much bigger than the rate of supernova that we see.
Okay.
So it seems like there's more large stars forming than there are supernova going off. So perhaps what people are thinking now happens is that all massive stars beyond a certain mass limit, like heavier than a certain mass, perhaps go through this way of collapsing down and making a black hole. So like skipping the supernova, or a failed supernova as people originally called it. So it's really interesting to think that this could be sort of explaining this sort of mismatch between the numbers that we have.
Oh, that's so interesting.
Yeah.
And I guess it also, like, some of this goes back to what we were talking about in our neutrino episode last month, where you kind of think that you might be able to see this happening or detect this happening with neutrinos, where you get like a massive flux of them, and then suddenly they just stop because nothing gets past the event horizon, right? And I really hope that we get to see something like that. Now that I know that that's a thing, I'm like, I'm ready for that to happen now. Like, please.
That would be nice. Yeah, exactly. It's just, I mean, obviously as you get to the more massive stars, they get rarer and rarer. So there's only a certain number of them, in our own galaxy that, at one time. And then also there's obviously like everything has to be at the right time to collapse, because a couple of decades that we've been able to observe this for like isn't a very long time in a star's life. Even the more massive ones that do live the shortest lives of a few 100,000 years, it's still like a blink in comparison. So it's just catching one of these things, and that's perhaps why we haven't known about it until now, until we actually caught one in the act.
I think so much of this episode is making us realise like space is really right place, right time to detect.
Yeah, a lunar meteorite, a direct cloud cycle, whatever it is.
Please.
Space vampires.
No, we'll never see them, Becky. That's the point.
You don't know. Never say never is. Just because of the current laws of physics, we don't understand we'll never see them.
Oh, of course, it's the current laws of physics that's the problem. Yes,
Yeah.
understood.
Yeah.
Okay.
Our
and
knowledge, of the laws of physics. Our current knowledge, not the current laws of physics.
Yeah.
Like, you know what I mean?
Yeah. Robert, Sarah wants to know about the Kuiper belt, however we're saying it. She says, "Hey there. First of all, congratulations on a podcast that is both entertaining and informative." Thank you, we try. I'm always rather impatiently waiting for the next episode. I was wondering what we know about the asteroid belt and the Kuiper belt. Where did all that material come from? Are the asteroids debris from early solar system collisions, or rather formed from space dust directly? Thank you for your great work. You're all stars.
Sarah, right. Hi, Sarah, and thank you from all of us as well. So for the benefit of listeners, the regions Sarah's describing are two distinct regions. So you've got the classic asteroid belt, which is between Mars and Jupiter and full of objects, rocky objects on the whole, a lot of rock and iron and only a certain amount of ice. And then the Kuiper belt is much further out. It's beyond Neptune, and it's strictly speaking, it includes the former planet, now dwarf planet Pluto. And Kuiper belt objects are made of different ices, so not just water, but methane, ammonia, other things like that, as well as some rock. Both of them are made over in some way from material left over from the formation of the solar system. And the asteroid belt has got lots and lots and lots and lots of rocks and rather bigger well, billions and billions and billions, you know.
That's a
yes,
technical
exactly.
term.
Yeah, it's like a lot. Yeah.
Specifically, 6 number of lots.
Exactly. Yeah. And right down to very small pieces up to Ceres, which is about 1,000 kilometers across. So, you know, everything up to moon size things, small moon size things. And they're strongly influenced by the gravity of Jupiter because they orbit between Mars and Jupiter, and that prevented them from coalescing to make a planet early in the solar system. And what it also does is it basically helps drive collisions as well. So you do see in the asteroid belt evidence of where two larger objects have collided and created debris fields and so on. So it does that to this day effectively. So although they're really quite far apart and we can safely send space probes and spacecraft through the asteroid belt, you know, it's not like Star Wars scenes where people are dodging asteroids in a spaceship. There's, you know, this still happens. Collisions do happen. And the source material for those would have been the original solar nebula. The asteroid belt is within the so-called frost line, just about. It's a bit, around 3 times as far away from the sun as the Earth is. And that means that it's warmish enough that a lot of the ice disappeared and evaporated. It's only about a tenth of the material in there now is ice. But if you go to the Kuiper belt, that's much further away from the sun. The nearest Kuiper belt objects are 40 times as far away as the Earth, and the most distant ones go out to 900 times further, maybe even further, really huge distance. And that means they're all cold. So they're much more pristine than the stuff, than the asteroids, because they're that much further out. So they haven't been heated by the sun in the same way. And they're much closer to being formed as space dust, you know, interstellar grains and so on, clumping together to make things eventually. They do that under the influence of electrostatic forces, first of all. The idea is if you look under your bed, I'm sure none of us have dust under our bed, but if you look under your bed and you see, I absolutely do as well.
My Uber can't fit underneath it, it's too low.
Dust sticking together, and then eventually when it's big enough, gravity pulls it together more. So a Neptune is nothing like as big as Jupiter, but so it's less dramatic in its influence, but that's the planet nearest to the Kuiper belt, and that helps shepherd them a bit. But even collisions, when they happen there, can be really slow. So if you remember New Horizons, when it visited Arakoth 7 years ago, and look it up, it's the object that looks like a snowman, essentially, two spheres stuck together. The idea is that they merge together at walking pace. So that's how gentle it is. So it's nothing like the asteroid belt with these violent collisions. You imagine you just two worlds stick together, walk towards each other that slowly and gently kiss, gently, you know, merge into one object. Quite incredible. So very, very different to the asteroid belt.
Yeah.
I remember Arakoth. It was the snowman.
Yeah.
Exactly.
It was so
around
cool. It was
Christmas
such a
as well,
surprise, wasn't it? It was Christmas time. Yeah, it was really well timed, but it was such a surprise. I remember when everyone saw that image, everyone went, wait, what?
Exactly. It almost looks dusty and fluffy when you see it. I think it's got a very soft feel to it compared with, say, planets with sharp craters and all these mountains and everything else.
I
And
once saw in like an edit of that Arakoth image to like Frosty the Snowman at Christmas time, where it was just sort of like wobbling around like to the beat of Frosty the Snowman. Now, every time I hear that song, all I see is Arakoth just like. La, 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 la.
It's more tasteful than vampires, isn't it?
Yeah.
Hey, well, Christmas vampires, space vampires. We'll see what happens there.
Maybe space vampires are benign. Do we think? You know.
But I think that also, I think there's that thing with space, right, where we assumed like all of these mergers are like massively dramatic collisions, and you're like, or sometimes they're just quite slow.
That's
and
very
smush.
sedate. 2 meters a second. I mean, that's strolling across a room. That's how fast it was.
It's even like galaxy mergers, right? Like, because you watch like the simulations of them happening, or you see an image of, you know, one in sort of the process of 2 galaxies merging, and it looks very violent, but actually it happens over like 2 billion years. So
You're
it would
like,
be the
oh.
slowest, most boring process. If you actually watch the simulation in real time, you'd be like,
Oh,
"What's happening?"
You'd be like, they've been here for ages. But actually, it was a great question, because I think we haven't actually visited this topic maybe since our first ever
cool.
year of the podcast.
Oh, yeah.
So I think we should revisit this later in the year, and do a bit of an update, because it will be 20 years since Pluto got the boot.
Yeah.
So,
And we
you
can
know.
talk about the sort of not mythical, but hypothetical Planet 9 as well.
Yes,
that might be out there.
Yeah.
Whether it's a
yeah.
black hole.
Okay, we'll come back to that then. We'll say that for later in the year.
That'll be fun. Yeah.
And Becky, our final question is obviously on multiverses.
Of course it is. It's everyone's
Yeah.
favourite topic. Everyone's a headache at the end of the episode.
So this is the point where we will always get emails afterwards being like, I have more questions.
Welcome to science.
Yes. So Adam Reeves has sent us this message. If other universes exist, would there be a risk of collision, connecting, or merging?
Oh, I love it. This ties into our previous question as well.
Yes.
It's almost like someone produced this show.
Who does that, I wonder?
Well, first of all, I definitely encourage all of you to listen to our multiverse episode if you haven't already, because it is one of my favorites that we've ever made, I think.
Yeah.
So again,
It's
the
got
mysterious producer who produces this episode will link that in.
It's got a little bit of science and a little bit of whimsy, something for everyone.
Yeah. So, I mean, collisions, connecting, merging, I think that would only happen or only be the case in the bubble universe concept of multiverses. So if you remember, is from that episode, there's like 2 main interpretations of the idea of a multiverse. So there's the many worlds interpretation, which is sci-fi's baby, sci-fi's favorite, right?
Yeah.
It's where there's every action or event or decision spawns another parallel reality somewhere, right? That could be classed as a multiverse. Rick and Morty, Spider-Man, Marvel, they love the multiverse, don't they?
I love them too. Yes,
They will.
correct.
Or there's the idea of what's known as like the bubble universe idea, where we're just one of many coexisting universes that are either expanding or contracting, or I say next to each other, but like we don't really know how they're distributed. It could be in higher dimensions, right? So it's just not something that we can really like comprehend necessarily. But theoretically speaking, the maths does say that they could like not really collide or connect, but it's more like a kind of like a bump or a graze or like a butt up to each other, you know. It's not necessarily like this like dramatic collision. It's more like I'm just coming for a snuggle, you know. Like I don't know.
A nuzzle, a little
multiverse nuzzle. Exactly. That should become like nuzzle sounds like it could be one of those terms that's been adapted by physics that has like a different physics meaning, doesn't it?
Yeah.
If it isn't already, we should make nuzzle a physics concept.
Yeah, this will be my legacy. Thank you.
Yeah, bubble universes nuzzle each other. And actually, through the nuzzle, one idea is that we could actually probe whether this multiverse bubble universe idea like is real or not. Because if I say we as in the concept of our universe were touching a nearby multiverse, like a bubble universe, that should have a lasting residual signal left on the cosmic microwave background, you know, this oldest light in the universe, you know, is the earliest light given off, and we now detected it as this sort of like background hiss of microwave wavelength of light. sort of in every direction we look in the universe. And so if we have a sensitive enough instrument to resolve that like tiny but noticeable signal that it would leave on the cosmic microwave background, that could prove the existence of the idea of bubble universes.
So maybe this is the whole point.
Izzie's cogs are turning and hurting.
I'm also very
mine, trust
aware. I'm now very aware that for the first time, people will see my face while you're talking, where I'm just going like, yeah, okay, all right. Follow-up question. What hypothetically would that look like?
We don't know.
Like, yeah.
Well, we have some like ideas through sort of like running the maths on the cosmic microwave background. It would be a noticeable pattern in sort of like, you remember what the cosmic microwave background looks like? It's sort of like red and blue and yellow splotchiness, right? So there would be some sort of pattern in the splotches, basically, that we could detect. It might be that it's like some sort of polarization pattern in the light. It might be a pattern in scales on the background. It might be some weird, like, extra residual in a specific direction that doesn't match. Because, so when we, how do I describe this? Now people are going to see my face as I'm like trying to puzzle out, how do I describe multipoles in the cosmic microwave background? So we like, when we fit the cosmic microwave background, we're like, okay, so there's this sort of overarching sort of, if you averaged out the cosmic microwave background and you were just like, what's the average temperature, right? It's like, that's the one thing you could fit. And then you could say, okay, well, what's the average temperature on this half versus this half? And then this quarter versus this quarter, and this eighth versus this eighth. And you basically sort of build up this picture of the cosmic microwave background by doing a big fit of all of those sort of averages, really. Yep. That's a very simplified way of putting it, but that's essentially kind of what we can do. And so if you sort of keep doing that, eventually there is sort of structure that you can't account for by doing that. And so if there was some sort of like leftover structure, but only in one specific part of the sky where we're nuzzling up to the closest multiverse, then that's how we would probably find it.
Thank you.
But it's just detecting how finely down do you go?
Yeah. Where does that scale end? Who knows? Yeah.
Also, people watching the video will see how much I use my hands and how much they flare sideways off the video frame so that no one can even see it, so they're not useful.
And also how much that I just stare into the distance like, yeah, okay, yeah. Amazing. Okay.
You know what I just thought as well, by the way? Since we're doing video now, what we should do is, if people do have questions, of course you can just email them to us. That's great. But if you want to send us a little voice note, people have done that before. But also, if you want to send us a little video of you asking the question, we can then play it. We can hear your voice. We can see your face. That would be really fun.
Yeah. But also voice notes too, just for our still audio-only listeners.
That is easy. Yeah, that was very much like I have to edit this.
And it's also, I'm such an audio nerd that I'm like, don't forget the listeners at home, okay?
Because make nice audio.
A lot of people will be just listening. But shall we end with some stargazing? So, Robert, what shall we be looking out for in August?
Yeah, I'm so tempted to say what we won't see in the sky, those little vampire things. Anyway, let's move on to stargazing. Right, okay.
Don't go stargazing with garlic, is all.
It's true, yeah. Or do go stargazing with garlic, maybe. Anyway,
everyone protect themselves from space vampires.
Exactly.
What's that like mythical Australian creature that everyone always says exists as well to tourists that they think is going to drop out of trees and get them? This is going to be a new thing. It's like space vampires.
It could be.
You have to take garlic stargazing just for the space vampires.
Just in case. Layers and garlic. Carry on, Robert.
Exactly. Where do I go? Right, August. Very nice month.
Sorry, that's what.
Very nice month.
I was going to say we're talking about koala used to scare travellers. Drop bears. Got it.
August is a great month for looking at the sky because it's still warm. We've got longer nights again and it gets properly dark. So nice, nice conjunction of things that make it really good. And I really love moonless nights at this time of year, dark side. And that's when you get the Milky Way that, stretching across our heads. It's really just so easy to see or imagine how we live inside a giant galaxy. So that's the sort of starting point, I think. Pick those binoculars up, use your eyes, look at the Milky Way, look at the Summer Triangle, Deneb Cygnus, Vega in Lyrac, Altair in Aquila that marks it out. And then down below that, even in the UK, it's much better if you're further south. You've got Sagittarius Sagittarius, and a bit to the west of that, Scorpius. And all of these things, there's too many to list really, but they've all got lots of clusters and nebulae, so open star clusters and clouds of gas and dust. And, some examples, you've got the star cloud Messier 24 in Sagittarius, the wild duck cluster Messier 11 in Scutum, and the coat hanger cluster, which I mentioned because it's slightly quirky and easy to see, and it really does look like a coat hanger in Sagittarius, and that you can see that with the pair of binoculars as well. So it's also a great time for people with smart telescopes. You can just get those out, point them at various things in the Milky Way. Like I got a really nice image of the North American Nebula a few days ago doing that. So we also have the solar eclipse, the total solar eclipse, which is partial in the UK on the 12th of August, but we'll pick that up in the bonus episode. All I will say is if you're not listening to the bonus episode, if you go to ukeclipse.com, there will be things like videos of how to see it and safe viewing tips. And that should be, by the time this episode goes out, that should be up and running. And that night of the eclipse is also the maximum of Perseid meteor showers. So fragments of Comet Swift-Tuttle burning up in the Earth's atmosphere. Just maybe, I would say look out for them impacting on the moon from late evening onwards. But sadly, ironically, there's no moon in the sky because there's been an eclipse that day. So the moon is completely new and thereby invisible. So that does make it a good year.
Sunset as well, or like
Exactly,
just before
yeah.
sunset. So you literally, it's like two birds, one stone. It's like go out with a picnic, watch the sunset, stick
It's
around, watch the
brilliant.
meteor shower.
If-
what a
exactly,
perfect date
exactly.
night. Can I just
I know.
I mean,
I'm kind of
and go.
annoyed.
Yeah, exactly. It should be.
I'm
should
going
be great.
camping the weekend before, and now I'm like, I think I need to go camping again.
I think you
Or
do.
just drive
I
out
think
of
you do.
London and just find somewhere
Yes.
dark. Find a hill with a view west.
We got.
I was in Brighton the other day with the hill up from Brighton, like when you get to the South Downs Ridge, that view that way. Watch everyone descend on that hill now. I'm so sorry,
The
people of
south
Brighton,
coast
but
and the
it's
is it the
gorgeous
south
that way.
coast, the west
Yeah.
coast of the UK is going to be great for the eclipse. We'll do this in more detail in the bonus, but it's absolutely true. Yeah, going west, going south, make sure you've got a good horizon where you can see the sun. But 2 weeks after the solar eclipse is a partial lunar eclipse, and that's just because they tend to run in patterns like that. That one's a bit antisocial. It's 5 o'clock in the morning is the peak on the 28th of August. 90% of the moon is in the shadow of the Earth, so it's not bad, and I'm going to try and have a look at that. But, it does, lots of things come into play here. One of the things I'm mentioning on a personal note in this, in case I disappear for an episode, is that I'm having surgery at the time of this recording, a couple of weeks afterwards. So I might be stuck at home for a few weeks, and I'm going to be asking my partner to take the smart telescope out for me, or being wheeled out into the garden to look at the eclipse. So we're going to see how it goes. But I'm sort of going to treat it a bit like the COVID lockdown and go and look at my immediate surroundings and the sky above me. So yeah,
nice.
which I think everybody else should do as well.
Yes. Yeah. So the next episode, I'm taking over from Robert from Stargazing. Don't worry. I've not offed him. He's just recovering from home because
tempting though it is, yeah.
I want the stargazing job.
Yes, I mean, and maybe people can just send us their photos while you're on recovery, Robert, as well.
They
just
can,
to
exactly,
see
yeah.
what
It's,
else people have seen around the world.
That would be really great, yeah. Well, it's for
all
Crohn's
best.
disease, so it's big surgery, but I'm hoping that I'll be up and about in a couple of weeks, which is my main consideration.
Everyone will be thinking of you and sending all of their best wishes your way, I'm sure.
Absolutely.
Thank you.
So, as we have alluded to, we will be back in a few weeks' time with a bonus episode about the eclipse. It's going to come out maybe a week or so just before, so you've got a little bit of time to get planning. And then, obviously, our neutrino episode opened up a can of worms. So our next main episode is now going to be about antimatter, because why not do more complicated physics?
I love this. See, now they get to find out that we also get to find out what our next episode is at the same time as everybody else does.
Surprise!
Anti-space.
I love antimatter. Oh, it's such a fun topic. I think because everyone always thinks, antimatter. It almost sounds more sci-fi than dark matter, but I'm like, no. Like, find a banana that's got antimatter in it. It's something that we know definitely exists and we've detected and we can use. And
why are
anti-space
bananas
vampires?
always...
Does that work? Would they annihilate space vampires? Is
But can I ask, why is bananas always the measure of something? Neutrinos, it's like even bananas. Emit,
so
neutrinos.
have you ever been told don't eat too many bananas in a day because they contain potassium?
Yeah.
So potassium has a naturally occurring like form of potassium. And the radioactivity that's produced is positrons, which is the antimatter version of electrons.
Yeah. Yes.
So,
okay. Well,
don't
there
eat
we
too
go.
many bananas because you potassium, because it's got antimatter.
Your antimatter snack. Lovely.
Yeah, exactly. I love a good antimatter snack. Anyway, please do show us any astrophotography that you managed to capture in the next month or so. Perseids shots definitely appreciated, and anything for Robert as well during his recovery, like we said, much appreciated too. Send them to @SupermassivePod on Instagram or the Supermassive Pod on YouTube, which you like and subscribe to. Or you can email your questions to podcast@ras.ac.uk and we'll try and cover them in a future episode. But until next time, everybody, happy stargazing.